Hi folks, I welcome to the section 3 word embeddings using GenSim. In this video, let's get some context on word embeddings before we start programming. So what are word embeddings? So word embeddings are learned representations which stems from the fact that similar words should have similar representation. They are dense, low-dimensional representation of data which can be fed into neural networks, which produces faster and better results in comparison to one-hot encoded vector representations. The reason being that one-hot encoded vectors are high-dimensional and sparse, and one-hot encoding represents the presence of a word in a sentence or a text corpus. But what if we could represent the word and at the same time encapsulate the meaning that the word holds? That is what word embedding does. So let's consider a text corpus which has got a vocabulary size of 20,000. So if we were to use one-hot encoding, it would have 20,000 inputs going in, which would mostly be zeros with occasional ones to represent the presence of a word, which is extremely inefficient for a neural network to learn, and it consumes a lot of memory. Let's look at two words, cat and book, which comes from a certain corpus. They are two real-valued vectors from a predefined vector space, wherein one vector corresponds to one word, wherein they are dense and distributed representation of words under the notion that words that appear in similar context have similar meaning, and their vector representation encapsulates that information. So let's make it concrete with two examples. Say a review, this is an awful movie, and another example, this is a terrible movie. The two sentences are same. The only differences between the two sentences are the word awful and terrible. So they have to have similar context and similar meanings. Further, we can perform contextual operations by performing vector operations on these learned representations. A well-known example in this domain is that of king and queen. So if we subtract the vector for men or man from king and add to that the vector for a woman, the response is equal to queen. These operations allow us to get great insights about the text corpus, and at the same time we can use them to be fed into neural networks for further operations. There are different algorithms that help building word embeddings, and the common ones among them are embedding layer, wherein one of the layer within the neural network design is embedding layer itself, thus learning the representation while training the neural network. The other well-known algorithm is word-to-vec, which is a predictive model which predicts the words in similar context. Glove is another well-known algorithm which builds the word embedding model by using the count of words that appear in similar context.